Today we're going to talk about the last part of similar figures, which is proving triangles are similar. I can prove two triangles are similar from either a figure or a statement. We have three types of similarity. The first being angle-angle similarity. Here you can see the symbol, two A's with the similarity symbol. Two triangles are similar if two angles of one triangle are congruent to two angles of another triangle. So we're going to take a look at two examples. Both of these examples have angle measures inside of them, meaning I need to show that all angles are congruent, meaning that they are the same from one triangle to the next. So if I know two angles, then that means I need to find my third angle. So in my first triangle, I have angle 90 degrees and 39 degrees. And then in my second triangle, I have 90 degrees and 51. So I either need my first triangle to have a 51-degree angle or my second triangle to have a 39-degree angle. But I'm going to subtract the angles that I have to see if I get the angle that I want. So I'm going to take 180 minus 90 plus 39. And so I am subtracting that value and I find out that it is equal to 51 degrees. So therefore, my angles are similar. In example 2, I have 68 degrees and 54 degrees in my first triangle. So what I'm looking for is either I'm looking for angle B to match this 63-degree angle. If it doesn't, then that means it's not similar. If it does, then that means it is. So when I subtract 180 minus 68 minus 54, I find a value of 58 degrees, and 58 degrees is not equal to 63 degrees. So therefore, these two triangles are not similar. The second type of similarity is side, side, side. This is where we have sides of one triangle are proportional to the sides of another triangle. I need to show that all three ratios are equal. That means I need to find the ratios in all triangles. So in my first triangle, I am going to compare my big side with my big side, my medium side with my medium side, and my small side with my small side. So I'm going to label them. This is my small side. I'm sorry. This is my small side, this is my medium, and this is my big. This is my small side of triangle 2. This is my medium side of triangle 2, and this is my big side of triangle 2. I'm going to set up my scale factors. So 144 compared to 56. I'm going to compare that with 162 and 63. And lastly, 234 compared to 91. And my hope is that they all equal the same value. So we're going to divide all of them. And in the first case, I get 18/7. And in the second case, and in the third case. So since they are all the same, I can say that triangle UVW is similar to triangle, going in the same order, of BCD by side, side, side similarity. In example 2, we're going to do the same thing. So let's label our sides small, medium, big, or large. Small, medium, big. So we want to compare. Let me make this a little bit bigger. There we go. So we're going to compare 5 to 3. Well, that can't be simplified, so I'm hoping that the other ones end up being the same values. So then we have 7 to 12, I cannot simplify 7 to 12, and since 5/3 and 7/12 is not the same, then these triangles are not similar. If I had found that both of them were the same, I would need to find the third one to be sure. Our last type of similarity is side angle side. This is where we have the ratio of two sides of one triangle are equal to the lengths of the two corresponding sides of another triangle, and the included angles are congruent. What that means is that I need two sides that are proportional and the angle in between them to be congruent. So when we look at these two examples, the very first example, I have vertical angle at angle B. So I already have my angles. So now what I need to show is that my sides are proportional. My small is proportional to my small, and my big is proportional. This is big 1, and this is big 2. It's proportional to my sides. So I'm going to set up my proportions of 88 to 32 and 165 to 60. And if they are the same value, then therefore I would have side angle side. The first one simplifies to 11/4. And the second one simplifies to 11/4. So therefore BCD is similar to triangle BMN by side angle side similarity. In our second example, we have two triangles that are put together. So we want to compare our small triangle with our big triangle. We know that we have reflexive angles here, so I already have my angle measures. So now I need to compare my sides. Well, in order for me to compare small to big, I need to go ahead and add my sides together to get my large values. So I'm going to compare 30 to 39, which simplifies to 10/13, and I'm going to compare 27 to 34, which does not simplify, so therefore we say that they are not similar because the sides are not proportional. Now we're going to take a look at two more examples before we get to our practice. So we want to determine if the two triangles are similar based off of the given information. I have no numbers here, which means I'm only looking at what's given. I know that angle U is congruent to angle M. So I already have one set of angles. So that tells me that it's either angle, angle, or side, angle, side. And since I have no sides, I'm going to look for another angle that would be congruent. Angle L is congruent to itself because it's vertical. So therefore, I can say that angle LMN is similar to triangle LUV by angle similarity. Our last example that I'm going to walk through with you is determining if this is similar, and because I'm given all sides, I'm looking to see if it's a side similarity. I'm going to compare big triangle to little triangle. So in my big triangle, I have side 109. In my little triangle, I have side 24. This simplifies to 83/3. Next, I'm going to go to the other side and have 126 compared to, oh, I'm missing that value, so I need to subtract 126 from 99, which gives me 27. And when I simplify this, I get 14/3. Since these are not the same, I'm going to say that the triangles are not similar. And if I want to just double check, I can compare 81 to 18 as well. And that gives me, again, another value. So they are not similar. I'm going to show you one question at a time. Please pause the video at the beginning of each question to try it on your own. Now that you've had time to try this, let's take a look at what the actual answer is. Because we are given two sides and one angle, our question is whether or not this is side, angle, side. So we already know that the angles are congruent, so that passes that test. What we need to do is figure out if the sides are proportional. So we want to compare the small side with our big side, small side with our big side. So we're going to set up our proportions of 42 compared to 112 and 51 compared to 136. Both of these simplify to 3/8. So therefore, we have triangle DEF similar to triangle UTS by side, angle, side similarity. Pause the video and try on your own. Now that you have tried this, let's take a look. We have angle 43 and angle 43, so we're going to try side, angle, side. We're hoping that our small side is proportional with our small side, and our big is proportional with our big. So we have 238 compared to 85 and 251 compared to 90. When I simplify 238 and 85, I get 14/5. But when I simplify 251 and 90, it does not simplify, so therefore these are not similar. Pause and try the problem on your own. Since I'm given all three sides, I'm going to try side, side, side. That means I need to set up three different ratios. Small to small, medium to medium, and large to large. I'm going to simplify all of the ratios, and since they all simplify to the same ratio, I can say that triangle KLM is similar to triangle KBA by side, side, side similarity. Pause and try on your own. Now that you've had time to try this, we are looking at either comparing side, 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 or because angle J appears in both of them, I'm going to say that it's congruent, and I'm going to try to show side, angle, side. So I only need to set up two ratios versus three. So I'm going to compare little to big. So because I have 55 and 22, that means this side is 33. So we're going to compare 33 and 55. And then we're going to compare 39 and 65. And both of these simplify to 3/5. So I can say that triangle JKL is similar to triangle JCB by side, angle, side similarity. If I wanted to show side, 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 I would need to show 36 is proportional to 60, which it is. Pause and try on your own. Now that you've tried this, let's take a look at this together. We are given that angle X is congruent to angle A. I'm going to mark that in my picture. Angle Y is congruent to angle B. I'm going to mark that in my picture. And that XY is 15, YZ is 12, AB is 25, and we want to find the measure of BC. So we are going to first note that triangle ABC is similar to triangle XYZ by angle similarity, so I can then set up a proportion to solve for my missing side. 12 to 15 is equal x to 25, so 15x is equal to 300, and therefore x is 20. Pause and try on your own. First, we need to determine if these triangles are similar. Because we know that A is reflexive on itself and I have angle C is congruent to angle B, I can say that triangle ABE is similar to triangle ACD by angle similarity, and therefore I can find the length of AC by setting up a proportion of 12 compared to x is equal to 3 compared to 5. 3x is equal to 60, and therefore x is equal to 20. And since AC is x, we know that AC is 20. In example 7, we have parallel lines NJ and MK. And since these lines are parallel, we know that they create corresponding angles. We also have a reflexive angle. So we know that the triangles LKM is similar to triangle LJN by angle similarity. So we can set up a proportion and solve. We first need to note that this missing side length is 16. 16 to 24 is equal to 6x plus 2 compared to 7x plus 7. I'm going to simplify 16/24 to 2/3 to make my multiplication easier. So I'm going to cross multiply. 3 times 6x plus 2 is equal to 2 times 7x plus 7. So 18x plus 6 is equal to 14x plus 14. We're going to move our x's to the same side. So we have 14x plus 6 equals 14. We're going to subtract 6, so 14x is equal to 8. I'm sorry, this should be a 4, not 14. And therefore, x is 2. Since we know that x is 2, we can find the measure of the missing sides. NM is going to be equal to 7, and ML is going to be equal to 14. Our last problem. Since we know that LM is parallel to QP, it creates two parallel lines, and LP is a transversal that has alternate interior angles congruent, and we have vertical angles. So we can state that triangle NLM is similar to triangle NPQ by angle similarity. So I can set up a proportion to solve for my missing values. 6 compared to 4 is equal to x plus 3 compared to x minus 1. So 6 times x minus 1 is equal to 4 times x plus 3. 6x minus 6 is equal to 4x plus 12. We're going to move our x's to the same side. 2x minus 6 is equal to 12. Add 6, so 2x is equal to 18, and x is equal to 9. And we want to know the lengths of LM. LM is going to be 12, and QP is going to be 8.